Hi guys, in this tutorial I'm going to solve question number 6, paper 41, June 19. Two particles A and B of mass 0.4 kilogram and 0.2 kilogram respectively are connected by a light inextensible string. Particle A is held on a smooth plane. Particle A on a smooth plane, we don't have frictional force, makes an angle theta with horizontal. The string passing over a smooth poly P fixed at the top of the plane, and B hangs freely 0.5 meter above the horizontal ground. The particles are released from rest with both sections of the string. So, given that the system in equilibrium. When the system in equilibrium, it's better to write the equation of equilibrium of each particle. Let me start with B. Start with particle B, limiting in equilibrium. We have its weight acting down, mg, and tension acting up. So weight mg and tension is T. And like this. This is the weight mg, and this is the tension. Limiting equilibrium, so tension is equal to mg. Now, for particle A, no frictional force. You have to show the components of the weight horizontally and vertically. This is the normal reaction, and this is the direction of mg sine theta. Here, mg sine theta, mg sine theta, normal reaction, mg cosine theta. Equilibrium, all the forces acting up is equal forces acting down. So tension is equal to mg sine theta. Enough information for the first equation, T equals mg, so tension, mass of B given 0.2, use G is 10, so the tension will be 2 Newton. Left hand side, tension S2 is equal, mass of the particle A is 0.4, times G is 10, times sine theta, so sine theta is equal to, sine theta is 2 divided by 4 is equal to half. Shift the sign, you can get the angle is 30. This is part 1. Part 2, it's given that instead that theta is 20. Now, in case of theta is 20, remove theta and write 20. When you decrease the angle from 30 to 20, this means that the system started to move, and when the system move, B move down and A move up. But if you increase the angle, A started to slide down and B started to move up. See, it's given that instead that theta is equal to 20, in the subsequent motion, particle A does not reach P. Particle A not reach P means A move up in this direction, and it's written for particle B remains at rest after reaching the ground without a rebound. This particle move down. We'll again to write the equation of motion for each particle. We'll start by the same way for particle B. When particle B move down, because its weight mg minus tension is equal to ma. But for particle A, the tension acting up, tension minus mg sine theta is equal to ma. By solving these two equations simultaneously, you can find the tension and acceleration. For the particle B, its mass 0.2, and here mass 0.4. Started to substitute 0.2 times 10 minus tension is equal 0.2 times acceleration. For the second one, tension minus 0.4 times 10 times sine 20, as it's given in part 2, is equal mass 0.2 times acceleration. Simplify, 2 minus t equal 0.2a. Simplify t minus 0.4 will be 4 times sine 20 is equal 0.28. You can solve these two equations simultaneously by adding. You remove t, you will get acceleration first. Then after finding the acceleration, substitute in any equation, whatever, first and second, you can find the tension. Or if we try to divide by this, if we try to add, see, if we add negative t and positive t, if we try to rearrange t is equal to 0.2a, second equation t minus 4 sine 20 is equal to 0.4, here is 0.4, 0.4a, by adding negative t, positive t cancel, 2 minus 4 sine 20 is equal 0.6a. So you can find the acceleration by dividing. 2 minus 4 sine 20 is equal to divided by 0.6. So the acceleration is 1.053. Then substitute in the first or second equation. If we substitute in this equation, tension minus 4 sine 20 is equal to 0.4 times 1.053. You can find the value of tension. T is times 0.4 equal plus 4 times sine 20. So the tension is 1.789, or three significant figure. Tension is 1.79 Newton. Or if we try to divide these two equations, 2 minus t divided by t minus 4 sine 20 is equal to 0.2a divided by 0.4a. Remove a, cross multiplication, solve the equation. You will get the tension first. After finding the tension, you can substitute in any to get the acceleration. Find the speed of A at an instant when B reaches the ground. When B reaches the ground, the velocity of A will be same. Let's now start with the particle B first. For the particle B, particle B starts from rest, so the initial velocity is 0. Acceleration found in the previous part, which is 1.053. And the displacement between the particle and the ground is given, which is 0.5. 0.5. So V squared equals U squared plus 2AS. The final velocity, V squared, initial velocity 0, plus 2 times acceleration 1.053 times displacement 0.5. Calculate, and don't forget to take a square root for both sides. 2 times 1.053 times 0.5 is equal to square root of answer. So V is 1.026, three significant figure, 1.03 meter per second. This velocity when the particle A reaches the ground, so same velocity when the particle move up. So same velocity, V is equal to 1.03. In part C, use an energy method to find the total distance A move up the plane before coming to instantaneous rest. For this particle A, first the particle A move up a distance exactly same like particle A, which is 0.5. So move a distance on inclined plane 0.5. Then from this point to move up to V is equal to 0. We can deal with this part by using forces or by using energy, but it's written here, use energy. So I will use energy, V is equal to 0. and we start with initial velocity found from the previous part, which is 0.3. To use energy method, this particle move up a distance. And this distance, if we try to get the vertical height from this position to this position, this is height, move a distance, let's say x. Don't forget the measure of this angle is 20 degrees, 20 degrees. As it's written here, it's given that theta is equal 20 degrees. This is part A, part B, part C, so we use the same information. This particle moves on a smooth plane, so there is a loss in kinetic energy, but is equal to gain in potential energy. Loss in kinetic is half mv squared, gain in potential is mgh, no need to use m. So have final velocity, the loss in kinetic, if we started to get the change, we'll use 1.03 squared is equal to, because its final velocity will be 0, mg is 10, h is the perpendicular height, you can use it as x sine 20. So x sine 20. From this equation, you can find the value of x, which will be half times 1.03 squared, then divided by 10 times sine 20. The answer is 0.155. This is the distance moved up. So the total distance is equal 0.5 plus 1.55. 0.5 plus this answer. So the final answer is 0.655. This is the total distance moved up. If it is not mentioned in the question, use an energy method. How to solve it? Let me explain this part. When the particle starts to move up, when initial velocity is 1.03, and move up till v is equal to 0. If the question how to get this distance by using forces, this particle after the string is slack and there is no tension, it moving up with tension minus mg sine theta is equal to ma. When the tension is slack and the particle move up because of inertia, so t is equal to 0, minus mg sine theta is equal to ma. So the particle decelerating by using this value, negative g sine theta. So the deceleration is negative 10 times sine 20. Then we can apply equation of motion. We have initial velocity, final velocity, acceleration. So you can find v squared is equal u squared plus 2as. So the final velocity is 0. Initial velocity is 1.03 squared plus 2 times acceleration, negative 10 times sine 20 times s. From this equation, you can find the value of s. Value of s is 1.03 squared, then divided by 2 times 10 times sine 20. You will get the same answer, 0.155. Then add the total distance, 0.5 plus 0.155. You will get the same answer. But because it's mentioned in the question, use an energy method, this is why you have to use this method. That's it. Thank you.